Okay, so now that you know how to write a formula, how to write a name, and how to balance the equation, we're going to put them all together and be able to write a balance equation from a description. Okay, so this means you got to figure out what the reactants are, what the products are, right? Meaning which side of the arrow they go on, and then what the correct formulas are, and then how to balance it. Now, I want to bring this up. There are 7 elements that are known as the diatomic elements. All right, so these 7 elements, hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine, when they are alone and unbonded, and by unbonded, that means that's what elemental form means. It means bonded. Then they're written with a subscript of 2. Okay, so you're going to see these often written as O2, N2, F2, Cl2, etc. Okay, whenever they are alone. If they are bonded in a compound, then they won't necessarily have that 2, and that's okay. But if they are alone, they have to have the 2. All right? So, given the description, draw an arrow, identify the products, identify the reactants, and then balance the equation. So it's just putting together the skills you already know how to do. So let's jump to our first example here. So industry makes ammonia by reacting hydrogen gas with nitrogen gas. We want to write a balanced equation. So the first thing you need to do is figure out what the reactants are, right? So you read the description and you interpret, all right, well, they say they're reacting these 2 things. So the 2 things that are reacting, those are going to be the reactants, right? And so you write them on the left-hand side. And because those 2 are both diatomic elements, you would write them with the subscript of 2. All right? And to remember that, just literally write down Honkelbrief on the top of your worksheet or whatever, right? To serve as a reminder. Okay? These are the only elements that do that. So the 7 of them, just remember them, learn them, remember the acronym. Okay, so those are my reactants. So then we write an arrow. And the product formula was given. It was ammonia, it's NH3. I wouldn't expect you to know ammonia, right? If it has a special name or if it's not an obvious one, we would give you what the formula is of the product. So like here, we're giving it to you. And now that you have the formulas for the reactants and the products, now you just have to balance. So to balance this, let's start here. This is the most complicated looking formula. I see that there's 3 H's here, and I see that there's 2 H's here. So the lowest increment between 3 and 2 is 6, so I need to make sure that I have 6 H's on both sides. So we use the 2. And by doing that, now we have 2 nitrogens, and we already have 2 nitrogens, but we do have to fix the H's, so we put a 3 there. Okay, so what you're doing is you're just writing the formulas, which you should know how to do by now because that's what homework 1 was about, right? Homework 1 and 2. And then you're putting them in the correct places and then you're balancing. So really it's not that much more of a stretch from what we've done. So let's try a bunch of examples. So practice equation 1. When calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. So you've got to first figure out what your reactants are. What are the things that are reacting? What do you think? Yeah, aren't we starting with calcium carbonate? Okay, so we've got to figure out what the formula for calcium carbonate is. Remember, if it doesn't end in IDE, that means you have a polyatomic ion. So you have to find carbonate. We've got to assemble the formula for calcium carbonate. So carbonate is CO3, but you need to look up its charge so you write the formula correctly. So what's the charge on carbonate? Yeah, Jake. It's a -2. And so calcium Ca has a charge of +2. So that fits together nicely. And that is my only reactant. Calcium carbonate decomposes, and we get 2 compounds from it. calcium oxide. So I have to check and make sure this formula is correct. The charge on oxygen is a -2. The charge on calcium is +2. Okay, that's correct. Those cancel. We have a neutral compound. And then carbon dioxide, which is not ionic. It's molecular, so I just need to take the 2 and make sure I put a 2 on O. And then I need to check and see if it's balanced, which it is. Okay, let's try another one. So when methane is reacted with chlorine gas, chloroform and hydrochloric acid are formed. What are my reactants? Methane and chlorine, yeah, the things they say are reacting, right? So CH4 and Cl2. Notice I put that subscript of 2 because chlorine is one of the diatomic elements. It's a Hankel-Briff. All right. And then they tell me what the products are. Chloroform, CH3, Cl3 plus HCl. Chloroform, if you've seen like an old Get Smart episode, like an old spy TV show or a movie, chloroform is what they would soak into a napkin and cover over someone's nose and like cause them to pass out so they could be abducted, right? So it's commonly portrayed in movies that way. Its actual effectiveness, is debatable. Okay, let's balance this. So this looks like most complicated, right? Notice how I have chlorines in 3 places. Here, here, and here. All right, so this one might be a little tricky. There's H's in 3 places, and there's only carbon in 2 places. So I would say let's balance the carbon first, so 1 and 1, but that's done, so there's not much to do there. So now we have to jump right in and start balancing the chlorines. So if the chlorines on the left side come in increments of 2, and currently on the right side we have 4, 3 plus the 1 is the 4, and your H's, you have 4 H's on the left, and you only have 2 H's on the right. So sometimes you just got to jump in and try some numbers, and if you need to erase them and change them, so be it. So let's start with a 3 here. All right, by putting a 3 there, what that does for me is that makes the number of H's on the product side 4, because I had 4 H's on the reactant side. Okay, so if the H's are 4 on both sides, now we move to the chlorines. 3 chlorines here and 3 chlorines here, so that's 6 chlorines. So I can get 6 chlorines on the reactant side, no problem. All I have to do is put a 3 here. Okay. Equation 3. Silver nitrate and copper are mixed. Copper 2 nitrate and silver are produced. So with these descriptions so far, they're kind of easy because they're giving to them in straight order. Like they're starting off giving you the reactants and then they're giving you the products. Okay, so these aren't too bad. So silver nitrate. I need to write a formula for silver nitrate. Ag. I need to look up nitrate and see what its charge is. What's the charge on Ag or on NO3? Yeah, Jake, what is it?
+1. And that's it.
Plus 1?
No, just 1.
Yeah.
Just,
-1.
yeah,
-1. Okay. So still, yeah, silver is +1. Yes.
Oh, yeah, I meant silver. Yeah.
Okay. +1, -1, so that goes together nicely. So we're reacting silver nitrate with copper. And it's just copper, right? It's not a compound, it's just the element. And so if it's just the element, you just write the symbol for the element. We're going to get copper 2 nitrate and silver. So copper, charge of 2, nitrate, the -1. So to make that formula work, we have to have 2 nitrates. When you are writing formulas, the most important rule is that your formulas are neutral. You have to check and make sure of that first. Okay? Make sure your formulas are neutral. All right, and then silver, by itself. So here's silver. Okay. So those are my reactants. Those are my products. Now I balance. Let's see, I've got 2 nitrates on the right side. Let's get 2 nitrates by doing that. I got now 2 silvers. 2 silvers. Okay. So again, there's not much here that's brand new that we're doing. We're just assembling little tasks that we already know how to do and putting them together into one problem. So try number 4 on your own. So this one's a little tricky because they might not necessarily be given to you in order. So, who thinks they got this one? Well, let's start with our reactants. What are our reactants? Looking for some help in the back rows. Ozzy?
Sodium iodide and bromine.
Yes. Sodium iodide. It's reacted with bromine. Is there anything I should do here? The heck? It is a diatomic element, bromine. Yes. Okay. All right, and now my products, they're saying we're making iodine, right? So we're making iodine. And there's another product, sodium bromide. Just like that, right? Right? Gavin?
The iodine needs a subscript too.
Iodine is also diatomic. Yes. Okay. All right. So now those are my formulas, and now we just balance. There we go. You guys get what we're doing? We have a description of what's happening. You're just going to be writing balance equation, which means you have to write your formulas correctly, which means you need to check your charges to make sure your charges are neutral. Unless, when is the time where you do not need to check charges, though? There's some compounds where you don't even bother wasting your time checking charges. Chris?
When it's ionic.
Ionic is when you do need to check them, yes.
When it's covalent.
When it's covalent, you don't need to check charges, because when it's covalent, it's just going to be a bunch of prefixes, right? They'll tell you how many there are. Okay. All right. We're going to do a little bit of this section here, 5.4, but we're going to jump down and do what's called double replacement because that's relevant for today's lab. So jump down, 5.4 section, double replacement. Okay. A double replacement reaction takes place between 2 ionic compounds, or 2 ionic reactants. Okay? And what happens here is that your ions trade places. So if we look here, closely at this, A and B are both cations. Remember how in a formula we place the cation first? Okay, and then X and Y are anions, and anions is the negative ion. So, when the reaction takes place, if they swap partners, then really the only way that they can align is with one cation goes with the other anion, right? So if we try to track this, basically this goes with this and this goes with this. So because your cations and anions swap partners, a compound like AB is not possible. How come we can't form a compound on the product side made up of elements A and B? Yeah, why?
Because they're both cations.
Yeah, because they'd both be positive, and if they're both positive, they would repel. For the same logic, I cannot make a compound made out of X and Y. Make sense? Those are both negative, right? If they're both negative, they would not approach each other. They would just push away. So that's why it's got to be positive with one, cation with the other, okay? All right, now, in general, this happens whenever you have two ion compounds, the ions, they swap partners. But more importantly, when you are figuring out what the new compounds are, you need to make sure that the compound product on the product side are neutral. Okay, that means you have to check the charges, and you might need to rewrite what the formula is and the subscripts are to make sure that it's neutral. So, example. Here we have sodium chloride. So the charges, sodium is a +1, chlorine is a -1. Okay? Bromine is a -1, copper is a +2. Because these are trading places, so this goes with that. This goes with this. So in my new compound between copper and chlorine, because chlorine is a -1 and copper is a +2, that's why we have a subscript of 2 on chlorine. That makes sense, right? Why that formula, how that formula is made neutral, right? But notice how when we first started with chlorine, it did not have a subscript. Whatever the subscript is on the left side is not necessarily going to be the same subscript on the right side. You don't just automatically bring over a number. The number has to make sense. The number has to make the formula neutral. Look over here, copper bromide. In this compound, bromine has a subscript of 2. But over here, there is no subscript of 2. Why isn't there a subscript of 2? Because it wouldn't make sense. Bromine is a -1, sodium is a +1, so that putting a 2 here would make it actually not neutral. Okay, so think of it as you break these apart first, you reassemble them here, and then you put whatever number you need to. Don't automatically carry the 2 over. All right, so let me give you a couple of examples and see if you can follow the pattern and write the formulas correctly. So let's try this. Here are 2 ionic compounds. I want you to predict what the products are. So write the formulas for the products based on the pattern we just discussed. So the first thing you need to do is look up the charges. You can't do anything until you look up the charges. And then you're going to reassemble the formulas. What's one of my formulas for the products? So. Either one. Give me one, Alexia. I will combine K and O, yeah. We have to tailor this a little bit. Ethan, what are you going to say?
K2O.
Yeah, we need two of them there, right? Because potassium is +1, but oxygen is -2. Okay, so. And then my other product would be between magnesium and phosphate. But I need to make sure it's neutral. That's kind of the golden rule with formula writing, making sure it's neutral. So +2, -3. How are you going to make +2 and -3 work? Same way we did it last class, right? 3 subscript here, 2 subscript here. If you'll notice, the subscripts on the right side are not the same as they were on the left side. And that's totally okay. In fact, that's kind of almost expected. You have to make sure the new formulas that you write are neutral. And you do whatever it takes to do that. Multiply them however you need to. All right, so the last thing we need to do is balance this. So let's start with this guy here. This bunch of stuff going on here. Let's 2 phosphates. Let's put a 2 here. That'll give us 2 phosphates. 3, that gives us 6 potassiums now. So if I put a 3 here, that gives us 6 potassiums. That now gives us 3 O's, so we put a 3 here. And now that's 3 Mg's, which we have now. Okay. This is a double replacement reaction. It happens when? When do you know to follow this pattern? 2 ionic compounds, right? You're going to predict what the compound products are. You're going to make sure those products are neutral, and then you're going to balance it. All right, we're just going to do one more to make sure. So what's one of my products? Trevor, you got one?
Barium sulfate.
Yes. BaSO4. Barium is a +2 charge. Sulfate is a -2 charge. That fits together nicely. Okay. All right, so then that leaves aluminum and the nitrate. So aluminum is a +3 charge. Nitrate is a -1. How am I going to fix that? What do I do? Yeah, subscript 3. Okay. All right, each formula is now neutral. And so I just have to balance. So let's start over here. 3 sulfates. Let's put a 3 here. That's 3 bariums. Come back here, put a 3 here. That's 6 nitrates. Come back here, put a 2 there. That's 2 aluminums, and we have 2 aluminums. Now we're done. Okay, that's how you predict and balance a double replacement reaction, which is the premise of today's lab. So let's